Okay, so let's unpack this. Imagine your company just launched like this sleek, brand new customer portal.
Oh yeah, big day for the team.
Right. You've invested serious time, serious money. The interface is gorgeous. Your customers can log in, upload sensitive tax documents, pay their invoices.
View their private medical records.
Exactly. And it works perfectly. It is just this massive, celebrated win for the business until, out of nowhere, someone realizes this terrifying glitch.
The worst case scenario.
Literally. While looking at their own private records, a user can just go up to the web browser, click on the URL, and change a single digit at the very end of the web address, like changing a 4 to a 5.
Just a single digit.
Yeah. They hit enter, and suddenly they are looking at another customer's highly confidential documents.
It is a chilling scenario.
Mm.
And, what makes it so terrifying is that it happens all the time.
Wait, really? All the time?
Oh, constantly. And when a massive data leak like that occurs,
Mm.
a lot of business leaders, they immediately assume some hacker broke through a firewall or maybe an antivirus software just failed.
Right, like some complex cyber attack.
Exactly. But that's not what's happening here at all. This is fundamentally an application security problem.
Right, because the server itself isn't broken. I mean, it's actually doing exactly what the code told it to do.
Precisely.
It's kind of like a bouncer at a club who rigorously checks your ID at the front door to make sure you're allowed in. But once you're inside, that same bouncer just watches blankly as you walk behind the bar and open the cash register.
That is a brilliant way to put it, honestly. The system verified who you were at login, but the application never bothered to verify if you were actually authorized to look at document number 5.
Yeah, you're in the building, but you shouldn't be behind the bar.
Right. And the industry term for that is broken access control. It's a symptom of a much larger crisis in how we build digital tools today. Application flaws like the one you just described are, well, they're the primary highways attackers use to steal data.
So we're talking big consequences here.
Oh, massive. We're talking about huge customer data exposure, financial fraud, intellectual property theft, and, wide open doors for ransomware gangs.
Wow. And that is exactly our mission for this deep dive today. We are going to prove to you that even if you sit there thinking, hey, I sell manufacturing equipment, I don't work for a software company, you are still entirely dependent on application security.
100%.
We want to reveal the surprising blind spots and how the digital tools you rely on every single day are actually built, and more importantly, how to actually lock them down.
Because, the stakes have really never been higher. The reality is, whether you are running a custom e-commerce website or whether your finance team relies on, a labyrinth of complex Excel macros.
Oh, those messy spreadsheets.
Right. Or even if you're deploying the latest AI-powered chat tools, someone, somewhere, wrote that code. Someone maintains it. And your business is ultimately the one responsible for making sure it's secure.
So to really understand how a flaw, like that URL vulnerability we just talked about, even makes it into the wild, we have to look at how software is traditionally built.
Yeah, we have to look at the foundation.
Because there's this pervasive mindset that security is something you just bolt on at the very end. But building software is a lot like building a commercial high-rise.
That's a great analogy.
You don't wait until the penthouse is fully furnished and the carpets are vacuumed and the tenants are moving in to finally inspect the plumbing and the electrical wiring buried behind the concrete.
No, of course not. Because if you find a major structural flaw at that point, you're tearing the whole building apart to fix it.
Right.
It's wildly expensive and just completely disruptive. In the engineering world, we call that construction process the software development lifecycle, or the SDL.
The SDLC. Oh.
Yeah, and the stages are pretty logical. You gather requirements, you design the architecture, you write the code, you test it, you deploy it, and, you maintain it.
Makes sense.
But the critical standard here, which framework developers often refer to as CIS Control 16, it mandates that security cannot just be a final inspection at the very end of the line. Security belongs inside every single one of those phases from day one.
So instead of just doing a final inspection, you're checking the blueprints for security flaws before you even pour the concrete.
Precisely. Businesses need to establish a documented, non-negotiable process that explicitly explains how their software is developed securely.
It can't just be a suggestion.
No, it has to be policy. You have to include security requirements during the brainstorming phase. You mandate peer code reviews during development. And you implement strict automated testing gates before a release is ever allowed to see the light of day.
Okay, but wait, hold on. Let me push back on that a bit. If a developer messes up and writes a bad line of code, say, that URL issue we talked about earlier, and we
Right.
catch it in a test. Shouldn't we just, like, fix the bug, push the update, and move on? Why do we need layers of heavy documentation and process for what could just be a simple typo?
Well, what's fascinating here is that just fixing the bug is really only treating the symptom. You're completely ignoring the disease.
Oh, disease.
Yeah. When the vulnerability is found, yes, you absolutely fix the code immediately. But then you have to perform a root cause analysis.
Okay.
You have to play detective and ask why that vulnerability was allowed to be typed into existence in the first place.
Oh, I see. Because if you don't find the root cause, they're just going to make the exact same mistake next week on a totally different project.
Exactly. You have to ask the hard questions. Like, was the developer never actually trained on access control?
Right.
Was the overall architectural design inherently flawed from the start? Did the testing software fail to flag it? Or, were the project managers pushing the team so hard on deadlines that they just skipped the security checks altogether?
Yeah, which happens a lot, I'm sure.
Constantly.
Yeah.
And if you don't perform that root cause analysis, your team is basically playing an endless game of whack-a-mole. You have to cure the process failure to prevent the actual code failure.
Okay, that makes perfect sense for code that a company's internal team writes completely from scratch.
Sure.
But let's be honest about the reality of modern software development, right? Almost nobody's writing everything from scratch anymore. It's more like a Frankenstein reality.
It absolutely is. Modern applications are stitched together using prefabricated parts.
Yeah, I mean, developers are using open source libraries, frameworks, APIs, all this prepackaged code with names like Spring Boot, React, and Angular.
Yep, they pull them right off the shelf.
And it makes total sense. Why would a developer spend 3 weeks writing a custom calendar feature for your app when they can just download a free pre-built calendar module from the internet in 10 seconds?
It's just efficiency.
Exactly. But if building software is like building a high-rise, what happens when all those prefabricated steel beams you ordered have microscopic cracks hidden inside them?
Then the whole building is at risk.
Right. We are moving from internal coding flaws to the massive, totally hidden risks of the software supply chain.
And this is where we see the vulnerability ripple effect.
The ripple effect.
Yeah, because if you are relying on an open source library to handle a basic function in your app, and a cybersecurity researcher discovers a critical vulnerability in that public library,
Then you have a problem.
exactly, suddenly your custom application has a critical vulnerability too. The prime example that honestly still gives IT professionals nightmares is Log4j.
Oh man, Log4j, that was just a global meltdown,
It
wasn't
was a
it?
true crisis.
Yeah.
Just a total nightmare. For context, Log4j was just this tiny, ubiquitous library used to log activity.
Right.
Basically the software equivalent of a security camera recording who comes and goes. And it was embedded in millions of applications worldwide.
Everyone used it?
Everyone. But a flaw was discovered that essentially allowed an attacker to not just be recorded by the camera, but to yell instructions into the camera that the entire system would blindly obey.
Wow, that is terrifying.
It was. Because this tiny library was hidden deep inside millions of apps, those apps were suddenly wide open to full system takeovers.
So how does a business even begin to defend against that? I mean, if you didn't write the code yourself, how do you even know it's broken?
Well, this is why comprehensive security standards insist on something called a software bill of materials, or an SBOM.
An SBOM. Okay, so an SBOM, that's basically like the nutritional ingredient list on the back of a cereal box, but for software.
That is a perfect analogy. You can't just say we sell software. You have to list every single third-party ingredient that went into making it.
Right.
You have to maintain a strict automated inventory. You need to know which external packages are used, exactly what versions are installed, and whether any of them have known vulnerabilities.
Makes sense.
Because the tragic reality of development is that a team will often install a highly useful library to solve a problem today, and then they never, ever update it again.
They just forget about it.
Yeah, it just sits there buried in the code base, getting older and more dangerous, basically turning into a ticking time bomb.
Okay, but putting myself in the shoes of a business owner listening right now, code is incredibly fragile.
It is.
If my IT team is forcing updates to the foundation every single day because some new alert popped up for a minor library, won't that constant shifting completely break the application?
Look, that is a very valid, real-world operational concern. Updating deep dependencies can absolutely break core features.
Right, it's risky.
Very risky. And that is exactly why you don't just blindly update everything the second an alert hits your inbox. You have to implement a strict severity rating system.
Okay.
You classify vulnerabilities as critical, high, medium, or low.
Oh, so it's pure hospital triage.
It is entirely about triage.
Right.
If an outdated library has a critical vulnerability, meaning, an attacker could exploit it right now from across the internet without even needing a password,
Okay, that sounds bad.
that requires immediate drop-everything emergency action. You risk breaking the app because the alternative is losing the business entirely.
Yeah, you have no choice.
But if a scanner flags a low-severity issue, say, something that requires an attacker to already have physical access to a server room to exploit it.
You don't panic.
Exactly, you don't panic. You schedule that fix during a normal, low-risk weekend maintenance window. Triage allows you to survive without constantly taking a sledgehammer to your own systems.
Okay, so managing internal code requires root cause analysis. Managing external code requires an SBOM ingredient list and constant triage.
Correct.
Someone listening right now is definitely thinking, this sounds exhausting. I'm just going to outsource all of this.
Oh, I hear that all the time.
Right. I'll hire an agency to build my app and let them worry about the security.
And that exact thought process leads directly into one of the most dangerous traps in modern business.
Yeah, here's where it gets really interesting. Because you can hire a brilliant freelancer. You can hire an expensive managed service provider. You can hire a massive SaaS vendor. You can outsource the heavy lifting of writing the code.
Sure, absolutely.
But if that application gets breached and your customers' private records are suddenly for sale on the dark web, the business is the one answering to the federal regulators. The business is the one facing the class action lawsuits and the furious customers. I mean, you can outsource the labor, but you can never outsource the accountability.
Never. The dangerous assumption is always, well, they built it, so they are legally responsible for securing it.
Right.
But when you look at established security controls for outsourcing, the burden on the business actually increases. You have to heavily vet the developer before you even hire them.
You have to interrogate them.
Yes. And if you ask them about security and their answer is just, don't worry, we follow industry best practices, that is completely unacceptable.
You need receipts.
You need absolute proof. You demand documentation, sample penetration test reports, and, concrete examples of their secure development lifecycle.
Wow.
And once you hire them, the security requirements must be explicitly codified into the legal contract. We're talking about strict vulnerability remediation deadlines, mandatory breach notification windows, and absolute ownership of the source code.
So no vague agreements.
None. If your vendor contract only talks about features, launch dates, and budget, you are flying blind.
And there's another major operational risk with outsourcing that we really have to talk about, which is environment separation.
Yes, this is a non-negotiable rule. An outsourced vendor, or honestly even an internal team, should never, ever be testing their new code directly in your live production environment.
No, because testing in production is like rehearsing a play during opening night with a live audience sitting there.
It's a recipe for disaster.
You could corrupt real customer data or accidentally trigger an automated system that sends 1,000 error emails to your actual clients.
Precisely. You must separate your environments. Development is the messy workshop. Testing is the safety lab. Staging is the final dress rehearsal. And production is the live stage.
Got it.
And crucially, live production data should never be copied back into the testing environments without being rigorously sanitized or masked first.
That makes sense.
A third-party tester doesn't need to see real social security numbers to verify that a web form works. And the vendor should absolutely never have the direct ability to just push code live to the internet without your business running a formal approval process.
Right. Let's bring back our high-rise construction analogy for a second. If you hire a contractor to build your building, it makes total sense to give them the master keys while they are pouring the concrete and running the wires.
Of course.
But giving an outsourced vendor permanent, unmonitored access to your live production environment, that is like letting the contractor keep a master key to your front door forever just because they built the place.
It's a completely unacceptable risk. You have to aggressively control vendor access, and you have to meticulously plan for the end of the relationship. Vendor offboarding is a critical and often ignored part of application security.
Right. What happens when it's over?
Exactly. When the contract ends, or even when just one specific developer quits the vendor's company, you have to instantly revoke cloud access, disable their VPNs, rotate API keys, and ensure all test data on their end is permanently destroyed.
And you have to actually own the code they wrote for you, right?
Absolutely. The source code repository should be owned, hosted, and controlled by your organization, with the vendor only receiving the limited access they need to perform the daily work.
Because what if something goes wrong with them?
Right. Imagine if the vendor goes bankrupt, or you get into a billing dispute, or they suffer a catastrophic ransomware attack. If they hold the only copy of your application's foundation, you are entirely at their mercy. You have to retain the keys to your own house.
So we've established the ground rules here. We know how to do root cause analysis internally. We know how to manage the supply chain with an SBOM. And we know how to lock down our outsourced vendors with strict contracts.
Right.
But here is the million-dollar question. If all these rules are so logical and so clearly defined, why are they so consistently broken? Why is application security such a massive global failure?
Well, it really comes down to a fundamental culture clash. There is a massive and honestly often toxic language barrier between software developers and cybersecurity teams.
They're hard to unpack that because typical developers are taught to care about very specific metrics, right? Like user stories, sprint velocity, shipping features, fixing bugs, and ensuring the app runs fast.
Yes, they are heavily incentivized and often financially bonused to build fast and ship fast.
Right.
And anytime they slow down, they are penalized. In all their university computer science programs and coding boot camps, they almost never hear the terminology that security teams just live and breathe.
Right, so security teams are speaking an entirely different dialect.
They really are. Security professionals talk about OWASP, which is basically the industry's master list of the top 10 most deadly coding mistakes.
So Osprey.
They talk about MITRE ATT and CK, which is a massive playbook of exactly how hackers break into systems. They reference NIST, which is the gold standard government defense manual. Developers just don't study these things.
Not at all.
For a coder, security is often boiled down to a few basic rules like make sure the password is 8 characters. And that's really it. They aren't taught the broader business risk.
So what does this all mean for the business then? How are developers supposed to secure the application if they don't even know the rules of the game?
Well, the vital insight here is that developers and security teams are actually trying to solve the exact same problems. They're just speaking past each other.
Okay, give me an example of how that translation fails in the real world, like on a daily basis.
Sure. Let's say a developer is assigned a ticket to write the code for a new user authentication system. In the developer's mind, they are thinking, okay, I need to build a sleek login page. I need to connect it to the database, design the user interface, and build a smooth password reset flow.
So they're thinking entirely about the user experience.
Yes, but the security team looks at that exact same project and they see a threat vector.
Oh, totally different perspective.
Exactly. Security team looks at the login page and thinks, this falls under CIS Control 5 for account management. We need to implement strict access control, and we need to mitigate specific hacker techniques for credential theft.
Right. It's totally lost in translation. The developer hears Department of No slowing them down, and the security team sees a developer acting recklessly.
Exactly. And historically, the solution was to force software developers to halt their work and read a 300-page compliance manual.
Which never works.
Which never works. The goal isn't to make them compliance experts. The goal is to give them contextual guidance so they understand that the code they're writing isn't just a feature. It is the literal armor protecting the business.
But expecting developers to learn entirely new risk frameworks on top of the constantly changing coding languages they already have to master, that feels impossible.
It was a massive hurdle for a long time. But this is where artificial intelligence is fundamentally changing the landscape. We are seeing a real paradigm shift.
Oh, AI is helping with this.
Huge help. Instead of a developer having to pause their workflow to decipher a dense governance document, they can now use AI as an on-the-fly, real-time translator.
Wow. How does that actually look in a developer's day-to-day?
Well, while they're typing in their code editor, a developer can simply ask their AI assistant, hey, does this database connection I just wrote violate any OWASP recommendations? Or which security controls relate to this new login feature?
That's amazing.
The AI bridges the gap instantly. It analyzes the code and provides security guidance at the exact moment the developer needs it, in the coding language they understand, explaining the why behind the fix.
That is incredibly powerful. You're correcting the behavior in real time before the bad code ever makes it to the testing phase.
Exactly.
And to make sure that baseline knowledge is actually improving, I know businesses are now using something called a developer security maturity assessment.
Right. It's basically a diagnostic checkup.
Mm.
An assessment can identify if your internal developers or your outsourced vendors actually grasp fundamental security concepts before they are allowed to touch your live code base.
That sounds like a must-have.
It really is. It allows a business to spot knowledge gaps and tailor their training. Because you want vulnerabilities caught and fixed in the developer's mind, not discovered months later in your live production environment by a hacker.
Right. Which brings us full circle. Application security isn't just an IT headache. It isn't just a coding problem. It is a fundamental existential business risk.
Yeah.
Whether you are building a massive e-commerce portal or you're just tweaking a simple internal tool for your sales team, security has to be woven into the DNA of the project from day one. You have to inspect the high-rise while the steel is being bolted together. You have to know exactly what prefabricated ingredients are in your software supply chain.
The S-bomb.
Right, the S-bomb. And you can never, ever outsource your own accountability to a vendor.
Spot on. And if we connect this to the bigger picture, it raises an important, frankly provocative question for you to take away from this deep dive.
Oh, let's hear it.
We just spent this entire time discussing how professional, highly trained software engineers struggle to understand and implement complex cybersecurity frameworks.
Yeah.
But today, we are rapidly moving into a world dominated by AI-assisted coding and low-code platforms.
Oh, wow, yeah, the whole citizen developer movement.
Exactly. Anyone in your business, from a marketing manager to a finance director, can now use AI to instantly generate custom applications, automated scripts, and data integrations.
Without knowing how to code.
They don't know a single thing about coding, let alone complex security controls or access management. They just type a prompt and the application magically appears.
They ask the AI to build a tool to process vendor invoices, and 10 seconds later, it's live on the network.
Right. So the question you have to ask yourself and your leadership team is this. If the seasoned professionals are already struggling to secure their code, who is doing the root cause analysis on the software being instantly generated by your business users?
That is a terrifying thought.
Who is ensuring that an AI-generated script built by your marketing team doesn't accidentally expose your entire customer database to the open internet?
Because as we learned today, it only takes changing one single digit in a URL to bring the whole house down.
Something to really think about.